Okay, these are your next section of notes. This is section 9.2, laws of logarithms. Okay, so there are 3 laws of logarithms, and basically it's just rewriting the problem. So that's what we're going to practice today. So our 3 basic laws have to do with taking a logarithm and rewriting it in a different form. Our first law is that if we have a logarithm of any base, of p times q, so they're multiplied inside of one logarithm, then we can write that as the logarithm with that base of p plus a separate logarithm, base a of q. So if 2 things are multiplied inside of a logarithm, we can write them as 2 separate logarithms added together. Similarly, if we have division, we can write that as 2 separate logarithms subtracted. So if we have log base a of p divided by q, that can be written as log base a of p minus log base a of q. Then our last law is that if we have log base a of something to an exponent, so p to the n, then that would be the same thing as moving that exponent to the front and multiplying it as a number. With these 3 laws, we're going to practice using them first forward and then backwards, and then you will have an assignment in my math lab, I believe. Let me check. Yeah, that's correct. Assignment in my math lab. So let's see. Express each of the following in the terms of log base a of x and log base a of y. So what we're going to be doing is we just want a logarithm with x and a logarithm with y, and we're going to be starting with problems that have both in them. So we're using those 3 laws. So let's look at this first example. Log base a of x, y squared. Well, if we have this, we have a law that says if we have 2 things multiplied, then we can rewrite that as 2 separate logarithms added together. So we can rewrite this as the log base a of x plus the log base a of y squared. There's also another law that we can apply. We can, when we have an exponent, we can move it to the front. So when we simplify this completely, we would have log base a of x will stay plus 2 log base a of y. That would be what they're asking for. We have a log x and a log y. This one's just times 2. So that's our expanded expression. So let's look at another one. Log base a of x divided by y cubed. So let's see. First thing that we can do, we have 2 things divided. So we have a logarithm law that says we can put this log base a of x minus log base a of y cubed. Then we can take that exponent and move it to the front. So again, log base a of x minus 3 log base a of y. So that would be simplified as much as we need to do because there are no other rules that we can apply. Everything is separated. Let's look at, I think just one more. Yeah. So let's look at this one. Log base a of the square root of ax squared divided by y. Whew. The first thing, always look at the biggest thing that's happening. The biggest thing that's happening right here is a square root. A square root can be rewritten as a 1/2 exponent. So this is log base a of ax squared divided by y to the 1/2. Our first logarithm rule that we'll apply here is moving that exponent to the front. Log base a, 1/2, ax squared divided by y. Then we have a division. So we can write this. Be careful because everything will now get the 1/2 because remember the square root was on everything. So every logarithm that I write has to have a 1/2. So this will be 1/2 log A of ax squared minus 1/2 log base A of y. We can continue to simplify. There is a squared, but notice it's only on the x, it's not on the a. So first we have to separate the a and the x, and then we can bring the squared down. So again, 1/2 on everything, 1/2 log base A of A plus 1/2 log base A of x squared minus 1/2 log base A of y. Let's see. Now, there are two things. Something from last week. When we have a base and what we plug into a logarithm, do you remember what that is? It's one of our properties, one of the last things that we mentioned. If our base and what we're plugging in match, then that makes that logarithm just 1. So we have 1 times 1/2 here. Here, we can bring the 2 down. We have 1/2 times 2, which is also just 1. So 1/2 times 1 is 1/2. Plus, this will just be the log base A of x minus 1/2 log base A of y. So that one has quite a few more steps in there to combine. You just want to be careful and make sure you do all you need to do and simplify everything that you can. That log base A of A is something that is easy to miss, but that just means base and what you're plugging in match. That means that'll just simplify to 1. The last thing that we're going to do is we are going to condense. Basically, just work these rules backwards. So condense each of the following logarithmic functions into one logarithm. So we're starting with them all separated and we're working backwards. So here we have 2 log base 5 of m plus 3 log base 5 of k minus 8 log base 5 of y. The first thing to check is make sure that all of these have the same base. They do, so I can combine them. Second thing, we always want to work our way backwards. So we're going to move these exponents would be where we start with this. We cannot do like the adding and subtracting until we've combined those. So we have log base 5 of m squared plus log base 5 of k cubed minus log base 5 of y to the 8th. Then what we can do, we have 2 separate logarithms added and subtracted. If we have 2 separate logarithms added, they're multiplied, subtracted is divided. So these can become 1 log base 5. So I will only write that once. Then it'll be m squared times k cubed divided by y to the 8th. And that's all there is to condensing this problem. We look at the next one. We have 3 log base 2 of x minus 4 log base 2 of x plus 3 plus log base 2 of y. All the same base, 2, 2, 2. Yes. So let's start with our exponents. 3 moves up, 4 moves up. No exponent there. Log base 2 of x cubed minus log base 2 x plus 3 to the 4th. And then this one just stays. There's nothing to change quite yet. So subtracting is division. So we write it with 1 log base 2. We have x cubed divided by x plus 3 to the 4th. Now be careful with this last term. It is plus, so it is times. So it's not going to be on the bottom. It would have to be a minus because bottom is division, top is multiplication. So we have a times y up top. Basically, the sign in front of the logarithm is telling you top or bottom. Positive is top. There's technically a positive here, which is why that x cubed is on the top. Negative is bottom. Okay. So we have 2 things in the top, 1 thing in the bottom. And that's how that works, putting them up and down. Then let's look at one more. So let's start with our exponents. Really, we just have 1 here. So this is log base 7 of 8x to the 1/2. This one does not have an exponent, 7. And this one does not have an exponent. To move up, I mean from the top or from the front. Then we want to look at what these say. So you want to be careful here because one of the most common mistakes, so don't write all of this because this is a mistake, is they start with the 8x to the 1/2, which remember can be a square root. So we can just write the square root of 8x. And then they put divided by 3. Then this is wrong. Then they see another minus, and you put divided by 2y squared. First of all, does that look right? No, it does not. We do not have 3-layer fractions. It is hard enough with 2-layer fractions. So no, 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 no. Just like I said on the last problem, positive means top, negative means bottom. If we have one thing that is subtracted, we already have a bottom. We don't need to make another one. So this just goes down where the 3 already is, 2y squared. 1 numerator, 1 denominator. Positive means numerator, negative means the denominator. So we could multiply that 3 and 2, and our final answer could be log base 7, square root of 8x, divided by 6y squared. So that's the end of this little part of notes. So you will move on to your assignment in my math lab now.